Hi, kids. Hey, I'm going to talk about accident reconstruction with you. There's actually a police officer in Lincolnshire. At least there used to be a police officer in Lincolnshire about 15 years ago whose name was Officer Green. And Officer Green's job was, if there was a bad accident in all of Lake County, his job was to go out to the accident scene and do some physics and then figure out which car was at fault. Actually, Officer Green would get paid lots of money for this because as a consultant, he would get paid up to $200 an hour. And this was, like I said, 15 years ago. So, you know what, kids? It pays to know physics. So let's say there's an accident scene. So let's say car A, ran into car B. And the police officer needs to go out to the scene and figure some stuff out. So let's talk about what the police officer would do. So if the police officer was there, the police officer would say, well, you know what? I'm going from this point to this point. Okay. So just like we always do, we draw a picture and then we make sense out of a picture. So let's say that we're going from A to B. And the police officer is trying to figure out who is at fault. Well, if the police officer is trying to figure out who is at fault, he needs to know how fast the cars are going. So his goal, and we're gonna do this for car A, so just so you are aware. So he would have to do this for each of the cars because assuming there would probably be skid marks for car B too. But he is looking for the initial velocity of the car because if he can find the initial velocity of the car, then he can figure out, well, you were going fast in the speed limit, so you're at fault or whatever it is. Well, when he goes out to the scene, he's going to measure this distance. Okay? On the road. If you've ever seen the tire marks on the road, that's what they're actually measuring. So he would measure that distance. So this would be a known because he would measure it. And then he's looking for this. So what else does he do? Well, he's going to assume that his final velocity is zero. Now, when he actually, testifies in court, he always says, well, the car was going at least this fast. Because honestly, if the car, after skidding here was stopped, there really wouldn't be an accident. But this is where they don't know exactly how fast they're going, but they can say, well, you're going at least this fast. Well, if you think about other variables, there's no way for him to know the time because he wasn't there. But so that means he has to find this. So okay, so he's got to find that. So what is he going to do? Well, he's going to do what every good physicist would do, and that's going to be draw another picture. He's going to draw an FBD. So this is a top view. Let's draw a side view of the car. So here is car A. Here's a side view. And the car was moving to the right. And while the car is moving to the right, okay, and slamming on its brakes, here are the forces that are acting. You would have the normal force, you would have the force of gravity, and then you would have the force of friction. Well, if you take a look again here, so he's going to do the next step, right, is perpendicular and parallel equation. Well, perpendicular, you're going to have Fn minus Fg equals 0. And then parallel, you would have Ff equals Ma. So again, that's what he's looking for. Well then, in order to find that A, what does he have to do? Well, he needs to know this. Actually, you're going to find out in the lab, he doesn't actually need to know FF. He just finds something else. But do you see, hopefully you see, if he knows this and he knows the mass of the car, and actually as it turns out, he's not going to need to know the mass of the car, as you're going to find out in the lab. But if he knows this and this, he can solve for A. And then if he knows A and he measures the distance, he then can figure out who is going or how fast the car is going. And then he can figure out who's at fault. And lo and behold, he gets paid lots of money to do physics. All right. Bye, kids. Enjoy doing the lab now.